Okay, 2D computer graphics and design representation. 2D computer graphics and design representation, that is the topic for today. Okay. As scheduled, you've got requested some series of lab exercises in the class. Okay, lab exercises in each class, mostly pass-fail based evaluation, and some additional scores, additional points will be given based upon your qualitative assessment. Midterm exam scheduled in May 23rd. Okay, next week is sort of midterm exam period actually, but we're gonna have some regular courses, and our midterm exam will be held in May 23rd. For the final project, you have two options, but mostly option 2, given professionals design work and your own 3D modeling, 2D drafting, 2D image representation, concept representation, design development representation, and overall design presentation in 10 to 15 slides, okay, pages. So 3 pages usually cover index, back cover, and 7 or even more pages to represent design concept, some pictures, reference pictures, floor plans, elevations, and 3D renderings, and so on, in order to present what is your design and design concept. Okay, so individual oral presentation at the end of the class in English. Okay, keep focusing on the course. Okay, okay, focus on the class. Okay, there is no second chance. Okay, due date, end of the class. Details going to be announced in the class or through the website about your midterm exam, final presentation, final project, and so on. Okay. As always, today's lecture topic listed here: 2D computer graphics and design representation. And today's lab exercise going to be very lightweight. Okay, today's lab exercise only deals with Adobe Photoshop, 2D bitmap raster image-based representation. Actually, we are not going to deal with some detailed aspects of Photoshop or any individual computer application. But anyway, Adobe Photoshop is very representative and important application in 2D computer graphics. So we're going to review and make some demonstration in using Photoshop. Okay, let's get into the course material. At first, at the beginning of today's lecture, let's review first, okay, as always, some overlapped part between, from the last lecture series. Let's take a look at again as a review for some background theories from the last weeks. The first one is terminology, okay? Taxonomy of design computing, taxonomy of CAD and graphics, so-called taxonomy of this class, okay? Terminology for this class: design, computing, computation, computer graphics, 2D, 3D, 4D, even ND, design computing, computer-aided design, and so on. There are several terms we need to take care of, but at the end, overall, I told you before, all those terminologies, taxonomies, eventually same, okay? The same keyword, design computing, or CAD, or just computer graphics, whatever it is, they all semantically same. That's my point, okay? So what is design? The definition of design, there are a bunch of thousands, millions of definitions for design, possibly available, but I put an emphasis on this engineering-oriented design definition, coined by Professor Chuck Eastman. Structured arrangement of design units. And design units are, firstly, physical element. Secondly, things that can be cognitive dealt with, okay? Designers can cognitive deal with, I mean, something non-physical, something conceptual. In other words, number one, physical thing. Number two, conceptual thing, okay? In other words, simply say concept. So you need to represent two types of design element. First one is physical one. Second one is conceptual one. So designing is the process. What is CAD? CAD is an iterative process that converts a designer's intentional model, which means intent, okay? Design idea in the brain of functional requirements into an extensional computer representation of the final product. So functional requirements determines design, okay? Not an art. It's not an art, it's a design. So functional requirements you have to define. Actually, it's a sort of different story. And computer representation, computational visualization. That is the main subject for your use of computers, okay? So CAD, CAAD, CADD, smart CAD, intelligent CAD, knowledge-based CAD, 4D, four-dimensional CAD, even n-dimensional CAD, we reviewed lots of those abbreviations, okay? So you know what those terms mean, okay? Abbreviation of CAAD, CADD, usually architecture, aided, design, drafting, smart, intelligence, knowledge, dimensional. All they are representing the abbreviations of CAD and graphics. We also reviewed digital design media, okay? In the definition of design mode definition is really simple. Mode of thought, something invisible. Mode of expression, visualized, but not yet realized. Mode of production, the stage of realization, okay? So in terms of reality, whether it's realized or not, we can distinguish two parts, realization part and non-realization part. In terms of before realization part, we can separate two. The first one is not visible, not represented. Second one is represented, okay, visualized. So this sequence is very simple, straightforward, but we can say that simple process is almost everything about design, okay? The most important thing is mode of expression, because we're going to deal with the mode of expression, exploiting a medium's unique quality to maximize meaning. We also reviewed digital design media. We design by hand for several thousands of years, but in last 40, 30 years, we use computers, designed by computing. So this 40-year history of computers have changed almost everything. That's what I told you, okay? That's why we are dealing with design computing in this course, okay? So in terms of design goal, human creativity area is still veiled, okay? Unknown. I mean, this part That is why we are taking design studio course, and you have to develop your own design ideas. But design authoring, design developing, design visualizing, analyzing design, and so on, they are all based upon computational processing, computational technologies. So that is why we are saying all this part design computing. Human creativity, goal, and computing technology means overlapped part, so-called artificial intelligence, machine learning, deep learning, design cognition, all they are something about overlapped between human creativity area and computational technology area. But our focus still in this part, especially on this part, visualization in 3D or 2D. Actually, in 2D is the subject for today, recent subject, okay? Next step to next week, we're going to deal with SketchUp-based 3D modeling and 3D representation of the building design, architectural buildings, interior architecture design. But anyway, not today, okay? Visualization in 2D, that's the subject for today. The class name is CAD and Graphics. In CAD and Graphics, what is the most important thing? I put the answer here. Mode of expression. We are all working in mode of expression. Design visualization in the domain of interior architecture design. That is simply explains why we are in this course, okay? Why we are dealing with this course at the freshman level, okay? Design is also a way of taking thought systems and applying them to visual equivalence. The term visual equivalence means equivalence between your idea and your visualization output, okay? If you are thinking about new chair and then you have to visualize such new chair system, not a Mickey Mouse, okay? That simply means visual equivalence, usually defined by exploiting a medium's unique quality to maximize meaning. Medium's unique quality. What if your media is pencil? In that case, you have to maximize the quality of the pencil. In other words, you have to be very skillful at using pencil, okay? 20 years ago, when I was in school, I took the similar course from you, okay? Drafting and hand drawing course, design expression course. But at that time, I used the pencil and some series of pens, techniques, how to draw different line thickness using same pencil, how to draw very effective hand drawing of products, how to draw buildings, how to draw trees, foliages, animals, trees, flowers, or some landscape architecture things, the shape of humans, and so on. Simply because my design medium was at the time pencil, okay, by hand drawing. How about nowadays? Of course, we can use pencils, but we are naturally handling computers. So that simply explains why you should be an expert in using computers, okay? Why we are taking this course, design computation, design computing. If nowadays we don't have computers, we only use pencils, rotary pens, or some ink-based pens for hand drawing. In that case, you have to train yourself for using such pencils, okay? Pens, hand drawing techniques. rendering techniques by hand, not computing techniques. But unfortunately, we are using computers. And most of our outputs, almost 100% our design outputs generated by or edited by computers. That simply explains why you should be an expert in computing, okay? So let's get into some fundamental aspect of our design representation. Design representation also simply means design presentation, okay? So in our domain, in our department, interior architecture design, what is design presentation? What is the subject of design representation? What is our main goal for design presentation? The first one is design presentation goal, okay? The objective of design presentation. What is your design presentation objective? Firstly, show your design idea and concept. Okay, I introduced you before. Design consists of physical thing, the first one, and second one is conceptual thing, okay? Physical thing simply means the shape of your design. Conceptual thing simply means your design concept, your something invisible, something very abstract definition about your design, okay? So this simple phrase contains almost everything, everything about design. The first one, design idea, physical thing, and conceptual thing, okay? Show, in other words, visualize. As a communication tool for designers, what if designers are working with only by spoken language, oral speeches? What if designers never show their design geometry? They only talk about their design, their shapes, their concepts in literal or spoken languages. How to figure out the shape of design? For designers, communication method, communication tool is drawing, okay? There are a lot of different type of drawings, but anyway, drawing is a communication tool, okay? So, very simple, okay? Nothing new, nothing totally new. You already, hopefully, and I believe you already very well known to the things described here. But anyway, let me put some summarized structure in this way. Design presentation goal is to show your design idea, in other words, physical thing as well as conceptual thing, as a communication tool for designers, okay? This communication tool contains text, animation, drawings, floor plans, amount of visualized elements. What kind of elements? Let's take a look at design, visualization elements, communication elements, diagram, sketch, draft, model, picture, slide, simulation, animation, multimedia, report, and so on, okay? All they are your subject for design presentation. Okay, let's take a little bit detail about design elements in design presentation, okay? The first one is plan. If you say plan, you may think only floor plan, okay? But actually floor plan, site plan, elevation, section plan, detail plan, ceiling plan, all they are so-called under the category of plans, okay? How about previous plans? The term previous plan means 20 years ago plans, okay, when I was the student of our department. At that time, I told you, usually we put an emphasis on the effect of plans. In other words, at that time, we didn't frequently use computers. Still, hand drawing was very important and critical. So, effects of plans simply means your drawing technique, your pencil, your pens, your rotring pen, your some minor techniques are very critical at that time. But the content, the design body, okay, design itself is the most important thing, of course. So nowadays, contemporary plans in digital plans, we can put more emphasis on the contents of plans. In other words, by using computer tools, especially in this kind of class, I'm not talking about your techniques of hand drawing. I don't care your skillful techniques, how much time you spend on drawing your floor plans by hand, and so on. We can put more emphasis on the main body of design. In other words, main contents of plans. We don't need to put emphasis on some unnecessary things, such as drawing techniques, visualization skills, how to draw different thickness lines using same pencil, and so on, okay? So, embodiment of designers' ideas going to be implanted in conventional plans. That is why plans still very important, okay? Very critical for designers. So among those design elements, design drawings, let's put some classifications, okay? Let's classify those things. Okay, if there are tables, diagrams, sketches, concepts, they are something formative, okay? What if you have floor plan, elevation, section, axonometric, isometric, perspective, and so on? They are under the classification of development drawings, okay? Not formative drawing. They are development drawings. How about specifications, material sheet, design statements, and so on? Something informative. They are informative drawings, okay? So we can simply put classifications. We can classify them in this category. Formative drawings, development drawings, informative drawings. Mostly we are focusing on these development drawings, okay? These are kind of concepts, okay? They're not going to be changed before you totally update your design concept. But they are totally updated, changed frequently based upon your development. And such information, spec, material, design statements, they are dependent upon your design development. So there are 3 classifications of drawings. And let's take a look, drawing types. If there are some drawings such as plan, site plan, ceiling plan, axonometric section, perspective, how to put some generalized classifications. This is same mechanism to computers and hand drawings. The most important thing is whether it's perspective or not, okay? Actually, a couple of weeks ago when we are dealing with SketchUp, I actually demonstrated you before. Comparison between orthogonal projection and perspective projection. Perspective and orthogonal projection, what are the differences? This orthogonal projection can be generated by conceptually by computers. Human eyes, your vision always take a picture in this kind of perspective projection, okay, in 3D. But take a look, orthogonal projection for side plan, floor plan, ceiling plan, even elevation section, they are front view, okay. Side view, floor plan view, they are all top view, okay, top view of 3D object. So front view, left view, right view, west view, east view, whatever it is, they are all orthogonal projection to generate this kind of orthogonal perpendicular lines, perpendicular visual representations against this kind of three-dimensional perspective. So, okay, actually, the axonometric, isometric, they are not perspective, but anyway, three-dimensional projection can be classified in this way. Two things, projection, drawing, and perspectives, okay? 1 point, vanishing point, 2 point, vanishing points, 3 point, vanishing points based perspective. So you can classify different types of drawings in this way. By using SketchUp, 3D Max, Rhino, or any other type of computer tools, we can make some computational drawings exactly based upon those different types of drawings. Let's take a look line types. Solid lines, grid lines, outlines, visible outlines, section lines, trajectory lines, center lines, dimension lines, lots of some different style, but they are notations, okay? Some symbolized style of lines, so-called industry standard, okay? Design presentation example. Let's take a look at some example. How about this? This is totally freehand drawing, but computer scanned, okay? You can take picture by smartphone. So this one is, anyway, digital presentation, simply because this one taken by digital pictures, your smartphone. Anyway, one example of hand drawing, okay, hand drawing sketch. How about this one? Design presentation example. This one is so-called 2D drafting. But it's not clear that this one has been done by CAD, computer, or hand drawing, okay? This one possibly a hand drawing. You can make some hand drawing in this style in very long time, okay, by using rotating pen or some professional tools for making this kind of drawing. Very conventional and really time consuming, tedious. But someone did this kind of drawings for several hours previously. But nowadays we use computers not only for drafting this kind of 2D drawings. Instead, we are making 3D model, BIM model, and then all these kind of drawings can be extracted, automatically generated by 3D models. So this one was the subject for last week's your AutoCAD drafting for simplifying this drawing in order to make your own CAD file using different layer system and some notation system, something like this, but even much more simplified version. That's what I asked for. Okay, anyway, all they are 2D representations. And how about 3D design presentation? design representation example. The left one is axonometric, right one is isometric. Actually, this one is 90 degree, exactly 90 degree, which means this one is realistic, but it's not looking stable. Instead, this one is looking stable, but this one is exaggerated. The angle for this one is 30, 30. Rest of the angle is 120, okay, 120. So total 180 degree. But in this case, 90 degree and another perpendicular 90 degree angle for making that axonometric. Which one is looking better? Of course, isometric, okay? So that is why we are using some conventional way of isometric. Actually, ISO, the term isometric, ISO means the same ISO we usually say, okay? How about design, among design presentation examples, how about perspectives, okay? 1-point perspective and 2-point perspectives. Another one, 3-point perspectives. Perspective drawing by hand, but all these are easily generated from computers, computer models. Let's take a look at this example. How about this? How about this building representation? How many vanishing points in this drawing? How many vanishing points? 3? Okay. One vanishing points, and another one, and the third one, okay? Third one on top, somewhere on top, okay? So 3 vanishing points. Is this building is looking good? Of course not, okay? This is bad representation case. It's wrong representation example, okay? This kind of building representation is really bad representation. You have to put only 2 points vanishing perspective. That's my point. Take a look. There is some of the vanishing points. It's not so good perspective for building, for 3-point perspective. Let's take a look at simple example case. It's not important what is this design, what is this picture. My point here is, let's take a look at its vertical lines. Okay, this one is 1-point vanishing, but for this object, anyway, 2-point vanishing points it has. But it's not 3 points based perspective, because entire vertical lines are parallel, okay? Okay, they are totally parallel. So no vanishing points on top or on bottom. So maximum, this one is 2 vanishing points. This is professional picture. Let me show you some more example, okay? Okay, in Google, let me type interior design and let me open image search like this. Okay, I'm not sure that even if you type interior design or interior architecture design, whatever it is, it's not 100% sure that all the images searched by Google mean they all professional pictures. In other words, I'm not sure that they are taken by professional photographers or amateurs or some students. I don't know. I don't care. But you can find out at least one thing, okay? All the pictures here are totally, there are no 3-point vanishing, no 3 point-based perspective. They are all 1 point or 2 point, okay? All vertical lines are totally orthogonal, 90 degree, all parallel, okay? That simply makes your picture professional, okay? Let's take a look this kind of picture. Any vertical lines, any of them are totally parallel, 90 degree, okay? But take a look your picture. Your picture by your smartphones usually angled, okay? In this way angled or the other way angled, not perpendicular, not parallel. In other words, your pictures, your photos, mostly 3-point based perspective. And that kind of pictures are not that good for design, okay? Now, if you learned interior architecture design, even if you are freshman, from now on, you have to know this very simple principle, okay? Parallel vertical lines. In other words, always your pictures and what others, your rendering, okay? Your computer rendering scenes must be at least 1 or 2 point vanishing points, not 3 points, okay? Take a look, entire examples described and represented here, all they are fit the same principle that I mentioned today, okay? 2 point vanishing points, nothing angled. But let me show you an example, okay? And then at the end, you always get this kind of eye level view, okay? Professional renderings, professional pictures are all like this, simply because they know human eye level, okay? In human eye level, they always take the picture like this way, always parallel vertical lines, 1 or 2 point vanishing perspective. This is really, really critical, important aspect you have to take care of. Very simple principle, but okay, in the final presentation, I really put a lot of emphasis on this kind of simple principle in design visualization, but take a look your final rendering, final pictures, your final design presentation. Something not professional looking images you're gonna use. But hopefully you can figure out why this is very critical and important. Okay, let's go back to the course material. Design presentation examples. The first principle that I explain you today was really, really simple and fundamental principle, okay? 2 vanishing point space. Entire vertical lines must be parallel, 90 degree perpendicular in your view. That is so-called professional looking human eye level view, okay, for both building exterior and interior, mostly interior for interior architecture design. Okay, let's take a look some more fundamental examples. At first, let's take a look this concept sketch. 3 rows of buildings, 3 rows of houses, but the third one is rotating 90 degree, distorting. It's not clear what it means, but take a look the shape of this 3D. If you see this building 3D perspective only without this concept diagram, it is not easy to figure out how to make this kind of visualization. Why this is the geometric shape of this building? How about this section drawing? it's not clear why this building is so distorted, angled, bended. But in this concept diagram, this simplified concept diagram explains almost everything about this building's shape forming, okay? It's called Idle Tower, designed by this one, from Idea design book for professionals. Next example shows you some concept diagram, concept representation, 3D projection in this way, very orthogonal and something formative representation in 3D. Final output 3D perspective is looking like this. But when you see this 3D rendering, you can figure out, okay, this building is something like co-housing apartment, but it's not easy to figure out the entire building mass, how this building mass is look like. So this kind of concept sketch, 3D projection, 3D diagram helps to figure out the shape of this building. Next case shows you this animation, Comic and Animation Museum, designed by MVRDB. MVRDB is also one of the world famous design architect firm. If you see this 3D shape, of course this is organic shape, round shape, 3D some egg looking shape. But how about floor plan? Floor plan for this one, actually there is no floor plan, but in this case, section drawing is very informative and useful for visualizing the shape of this geometric structure, okay? As well as some more 3D interior rendering scenes. So they are some examples in design presentation. Okay, let's review another thing for technical aspects of 2D graphics. Technical aspects simply means something about this file types, file formats, as well as some technical aspects regarding the file formats, raster, bitmap, vector, and so on. So vector versus bitmap, I showed you several times. In magnification, you can find out the difference between vector and bitmap. Vector is totally line work based and raster is totally dot matrix based. So pixel by pixel defined visualization is bitmap raster. So what if you have amount of pixels? I mean large scale, okay? Many pixels width, many pixels height. That's enough, okay? That's good. So this is the example of bitmap image, and this is the example of vector. And also this is an example of still bitmap, okay? And another bitmap. What's the difference? 300 by 400 and 3000 by 4000, but same image. They are both raster, okay? No vector. But if you have higher resolution, you can avoid this kind of problem. So my point I told you last time was simply take care of number of pixels in width and height, okay? That's exactly what you have to take care of. And also we reviewed file types, okay? There are two file types, raster and vector. Under raster, famous JPEG, GIF, PNG, TIF, BMP, Photoshop, lots of raster file formats. Under vector formats, 2D and 3D, AI, SVG, Illustrator, they are 2D vector formats. How about 3D? AutoCAD, DWZ, DXF, SKP, SketchUp, 3D Max, 3ds, lots of Rhino files as well. A lot of 3D vector formats are available and compound formats, representatively PDF, okay? So all they are different file formats and screen resolutions. Traditional 4:3, wide monitors 8:5 and 16:9. I mean golden ratio for digital HD TV. And also I showed you some comparison between, take a look. This blue screen means DVD. Probably some of you may remember 10 years, 15 years ago, 20 years ago, when DVD released to public, DVD believed that this is very high quality video for video rental or TVs, whatever. But take a look. This DVD is much smaller than even 720p HD, really smaller than full HD. But nowadays we are using 4K UHD. So this simple comparison shows you number of pixels. Okay, UHD has 2 times bigger number of pixels in width. So overall, 4 times more pixels it has. Okay, so roughly 4K UHD is 4 times bigger than 1080p Full HD. Okay, anyway, nowadays 4K is available. And the last thing, the concept of DPI and PPI, dot per inch and pixel per inch. Dot per inch for printing, pixel per inch for display, or image scanner, or image sensor. Image sensor means your camera, your photo detection device, okay? That's why I showed you this kind of 2-axis based, smaller screen, larger screen, lower resolution, higher resolution. But in a nutshell, anyway, at the end, what you have to remember is take care of number of pixels for width and height, okay? For both working on top of computer screen and working for printings. Actually, you need to differentiate the concept DPI, PPI, and the concept of dot per inch, pixel per inch, retina display, the quality, CMYK, RGB, lots of things we have to deal with, but fundamentally, we need to take care of the more pixels we have, the better quality we can do for both printing and computer screen visualization. That's my point. Okay, get into the computer interface and more, okay? We are dealing with CAD and graphics. We are dealing with computers using computer interface. So how to use computers? Actually, last time we reviewed this one quickly. Menu systems, icon system, toolbar systems, grouped icons, grouped toolbar, so-called ribbon interface. By typing, by clicking, dragging and dropping, keyboard stroke. That's exactly what you are working for in front of your computers, your laptops, your personal computers. For design, for word processing, for gaming, for whatever, when you are working for computers. So-called graphical user interface, okay? But actually there is the former one, CLI, command line interface, and nowadays new development of interface, NUI, natural user interface. Nowadays we are using both GUI and NUI, but the problem of your CAD and graphics tool, they are partially based upon CLI, mostly based on GUI. Actually, NUI is supportive, but it's not precise, not that good. So this is the gap between general software we use today and the general computer graphics software. For efficiency and precision, even if NUI support voice recognition, if you say 500 millimeter for thickness, it's not easy to make sure that it's 100% recognized by computers. But what if you type keyboard 500, precise, okay, in AutoCAD or 3D Max system? So this is the CLI. This is the GUI. This is 3D Max interface. The problem of GUI simply displayed in this screen. Okay, this is SketchUp, comparatively looking easy, but 3D Max, too many buttons, too many manage systems, too complicated icons. It's not easy to figure out what to do, how to do. That's the problem of GUI. But NUI is really intuitive, easy to use, but not that precise. Okay? Your touch, your motion, your voice, your moving retina, your moving eyes, sometimes it's very easy and intuitive, very good. But as a design tool, as a communication tool, it's not sure that 100% you can guarantee that your input, your numbers, your precise design intent going to be delivered by such interface without keyboard, typing, mouse clicking, and so on. Okay, anyway, basically for 3D or even 2D design visualization, most of 2D, 3D computer graphics tools have GUI base. Some CLI also required. Last week, you used AutoCAD, Type L and spacebar, and then you can draw lines, okay? That is so-called command line. NUI, mobile environment, tablet-based design tool, but mostly viewers nowadays, not editors, not design authoring tools, making your 3D design models using GUI close to 100%. Okay, only GUI, which means only mouse and 3D geometric modeling based upon mouse click and keyboard stroke, only GUI. How about others? Okay, ideal interface for 3D modeling is here. Something NUI based and GUI based. In other words, how about laser scanning? How about image processing, photogrammetry? Something beyond keyboard and mouse, okay? How about hologram? A hologram representation visualized in the movies, like Star Wars, okay? 3D map visualization using hologram, robots, something virtual reality based representation. They are good for design, visualization, and recognition in 3D, simply because they are 3D, okay? They are not drawings, they are real 3D objects. Tangible devices for manipulating 3D objects. What if you have glove and you can make something like this in 3D? That one is much better than mouse clicking. But in reality, actual 3D modeling tools interface are here, handling 3D objects on 2D screen. You have to open top view, front view, right view, and edit them for precise control of 3D geometry. You have to handle 3D objects on 2D screens. Too complicated 3D modeling on 2D views, too many icons. That is the limitation of GUI. Too complex options, too many functions, sometimes overwhelming, too complicated. So this gap simply makes you hard to get computer graphics tools, okay? Let's take a look more example. 3D scanner. How about this laser scanner? You know what is laser scanner? Do you know the mechanism of laser scan? Very easy, okay? Laser beam detects the distance from origin point to the object. Millions of points, so-called point cloud, will populate this kind of geometry, okay? What is the limitation of this kind of laser scan? It's only available for existing geometry. If this building is not existing in real world, there is no way to capture this geometry, okay? That's one big limitation, actually. Let's quickly look at a video for figuring out the mechanism for 3D printing. 3D laser scan. Okay, this is one of the advertisement from Faro Laser Scan that is kind of world famous laser scan company. But anyway, this video will be useful for figuring out the fundamental mechanism of laser scanning. Okay?
Taking the world from 2D to 3D, Faro is a global technology company that develops portable 3D measurement and imaging solutions. Faro's commitment extends well beyond product performance and constant innovation. With Faro, you have 3D measurement peace of mind. The Faro Laser Scanner Focus 3D is a high-speed 3D scanner for the detailed measurement and documentation of large objects, spaces and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic, three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's 2 rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete 3-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. Faro's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor and compass, to create a cohesive point cloud.
The building industry is primarily developing towards the renovation of existing buildings for which plans and drawings need to be prepared. For this, laser scanning is the perfect tool.
Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for 3-dimensional building documentation, monument preservation or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. Reichenbach Architects in Hanover offers scanning services aided by professional hardware and software supplied by Faro. As a result of the innovative possibilities of 3D laser scanning, the market is expected to grow enormously in the future. At Faro, our focus is on simplifying our customers' work with tools like the laser scanner that empower them to obtain data more quickly, easily, and with less cost than ever before.
Okay, let me show you a real example. When I was at San Francisco, thanks to one of my friends for CCA. CCA is one of the colleges in San Francisco. Anyway, take a look. Millions of dots, okay? This is the picture, actually not a picture, not a movie. Point clouds, okay, taken by laser scanner, laser scanning device. So millions of points. Actually, this is kind of old version, so not that high density. But anyway, thanks to this kind of point cloud, you can measure, you can get real 3D geometry. This is the inside of this building, okay, CCA building. And you can navigate like this way, building exterior, building interior, as well as some structure, walls like this, okay? Okay, more examples for laser scan. The laser scan, we used this laser scan for scanning this room as well as the lobby space of this building. Take a look. Placing the laser scan over there, and we scanned this room, okay? The scanned output displayed like this way. This is the, you may recognize the place of this one. This is our first level lobby, okay? ATM machine and stairwell, elevator halls. Take a look, some more visualization on top view and some other space, and even some people captured like that way. Exterior view of this building, the first floor lobby, and this is the interior view of this laser scan view. And also there are some more things, image-based scan for objects or space, so-called photogrammetry. Photogrammetry, take a look, a lot of DSLR cameras, okay? This is the prototype of photogrammetry. In 2011, and when I was in Autodesk San Francisco office, this device was prototype application, and they are developing an app. At the time, there was no app, but anyway, under the development app using those pictures. So sitting in this chair and taking picture at the same time, so total 12 pictures taken, and this is 3D, okay? 3D face. But this is not conventional. This is named 3D JK Lee, but at that time this was really, really brand new and interesting. But nowadays, you can get this kind of 3D very easily. Do you know 1-3D Catch application? Okay, let's take a look 1-3D Catch application as an example. Let me show you YouTube video, okay? Let's take a look this YouTube video. You can download this application free, okay? It's free, and iPhone, Android, both available. What you need to do is taking pictures like this, and then you can make this 3D, okay? After making 3D geometry, you can edit this one using PC version, okay? This is PC version of your 1-3D Catch. You can adjust for 3D printing or making some markup paperwork, okay, something like this, or Lego block. Whatever it is, you can regenerate your geometry based upon your scan, okay? Okay, this is 1-3D Catch example, and let me show you that application actually. You have that application, this application, I think. Okay, here it is, 1-3D Catch, okay? 1-3D Catch is the application you can easily download and use. Let me open this example, okay? This is 3D geometry taken by smartphone, okay? What you need to do is taking pictures, at least 10 or 12 pictures surrounding this object like this. And then you can get this kind of geometric shape, okay? Close, and a lot of more examples. What if you visited some historic site, something like this, somewhere like this? What you need to do is taking your own pictures, okay? This is just sushi, okay? Let me open this one. And let's take a look. What's this? You can take a picture and post it on Facebook or Instagram. But they are anyway just a simple picture. But if you take several pictures by using this kind of 1 to 3D Catch app, you can make them in 3D like this. Okay. Okay. 3D picture. The problem of this 3D picture is you can see opposite side of this picture simply because this is surface-based 3D. Okay, so this picture is, this side is good, but this side it's not good. Okay, it's not a good appropriate view. Okay, anyway, this kind of visualization is available by this kind of photogrammetry 1 to 3D Catch. Let's take a look at a little bit more detailed and advanced example at this time. Google Project Tango, smartphones to 3D building interior. As you may know, Google already scanned almost entire surface of this planet by using airplanes and satellites. Okay, that is why they already give a service for Google Earth, Google Map. Okay, but nowadays Google interested in indoor, okay, interior of buildings. Let's take a look this project. Actually, this is old project, not totally new project. Tango project. Let's take a look how Google acquired
and I work in the advanced technology and
indoor
projects group at
geometry.
Google.
Okay.
Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
Using mobile devices, holding mobile devices, and acquiring indoor geometry. This is the mobile device, okay? And acquiring, take a look, holding the device and acquiring indoor geometry, indoor 3D, without any specific modeling, okay? Using this one. Camera, sensors, motion tracking, and so on.
Its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that at the moment.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe in the vision.
Localization and mapping is there on your phone and you just use it.
It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
You know, being able to map your home. Oh, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. We are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.
Okay, this is actually one tiny snippet of advanced technologies. Actually, this is kind of old project, 2-3 years ago. But anyway, this one simply shows you how smartphones used for getting 3D building interior geometry. And also there is an object scanner. Small size, easy to use scanner for objects, not for space actually. This one easily used for scan human face or this kind of object, something like 1 to 3D catch in order to generate something like this human face and 3D prints, okay? That's me, okay? Scanned by this scanner, okay? This kind of scanner. This is totally laser scan based as well as image photogrammetry based scan. So let's take a look at some easy case using this application, okay? Okay, let me click this. We can choose person or object. How about object? Small object. And then, okay, let's take a look. Okay, here is the object recognition. So let me use this one. Start scan. And let's, okay, some problem happened, lost tracking. Okay, discard scan, okay. Okay, let me do not save this one and let me scan again. At this time, let me scan the mouse, okay, this one. So click object, click small object, and this one. Okay, it's not easy. Start scan. Okay, start to scan. Okay, it's not easy. It's not easy, but anyway. Do you want to take your head? I can do that. Because this one is not that easy to take. It's still lost to tracking. It's not easy because this is too small. But if I click human face, okay, something like this, person, head, and then, just a second, let's take a look. Okay, if I click start to scan, and then I can get some tracked 3D, okay, something like this, something like this. Okay, actually this is not enough. I have to take more pictures, backside of you, but this is, I know this is not enough, okay? Empty, outside, backside. This is just a quick scan, okay? If you are interested, stop by my office, and then I'm gonna use tripod to take your entire 3D geometry. This one is looking very rough, but actually if you print this out using 3D printer, you can realize that this is really, really precise 3D geometry because this one is photogrammetry as well as laser scan base. I just use laser. Do you see the laser here? Red dots. This laser scanner is our asset. You can borrow this device from our department, okay? 1 hour for free. Anyway, this is one quick. No, don't save. Okay, I'm not gonna save this one. But anyway, let's go back to the course material. Thanks to this kind of scanning device, you can generate this kind of geometry. How about this one? This is real-world object. You have laser scanner or your smartphone, 123D catch. What you need to do is taking pictures, and then you can generate 3D geometry. In PC version of this 123D catch, you can adjust geometry and apply on top of your design, your interior design, from objects, okay? One way of application. Let's take a look at some little bit more about image-based scan for objects and spaces, photogrammetry. Thanks to Matthew Swartz from Georgia Tech, this is aerial photography for photogrammetry, for making 3D example. This is Midtown Atlanta, and this is the place, campus of Georgia Tech, okay? Drone took this picture. Not this kind of machines, okay? Real drones for taking this picture. Let me show you example video taken by us at that time, okay? So this is your senior students, and that's me, okay? 2 years ago, we used this drone for taking this picture, okay? And this is the student common building of Georgia Tech. So we flew this air drone for taking series of pictures. Let me quickly move the picture like this, okay? Going down to students, okay, people, and moving. Move up, and let's take a look. The camera placed on the drone is moving its head and take pictures for surroundings, okay? So this is looking like a video for fun. It's looking like just nothing, but actually it's not true. This is really, really useful video and picture for photogrammetry. Okay, let me show you how to use this kind of pictures, this kind of video. Take a look. This is one of the screenshots of the video, and take a look. Hundreds, even thousands of sequential video files, JPEG files, image files, high resolution you can get. So what can I do for those pictures? Take a look. This is something low density photogrammetry and a little bit high dense point cloud. And take a look, some dense point cloud as well as triangulated mesh. Take a look. What is this? This is the exact location of the drone flying. And take a look. G001941.jpg. This means the JPEG image file taken by drone exactly on this space. And then this one reconstruct 3D geometry based upon those sequential images, okay? So actually I have drone, okay? This drone, okay? This is the drone. Even if it's really small size, but we can install some type of sensors or some videos or any type of gyroscoping or some sensing devices and so on. Anyway, this is real drone, okay? Don't touch, okay? It's dangerous. This is real drone anyway. Okay? So controlling this kind of drone is really, really hard. But anyway, we can make some. Oh, okay, it's dangerous. But anyway, my point here is this is sort of toy drone, but we can use this kind of devices, drones, camera, sensors for anything, for design, for whatever, okay? Okay, it's really, really hard to control, but anyway, thanks to this kind of devices and applications, let's take a look the last example for today. This is Google Map, Google Earth, okay? I just opened Google Map for this site. Where is this? This is the site exactly I show you today, Georgia Institute of Technology, Atlanta, US, okay? This one is looking like some roughly generated geometry, but if you click Control, now you see this is not just a simple 2D or 3D map. This is exactly 3D modeled geometry. And take a look this area. Do you recognize this building? The drone taking video file recorded from this point. At that time, including me, some students are standing around here, and this is Georgia Tech Student Common Building. And drone is moving from this point and going up and taking videos, okay, in this area. So this is, of course, Google generated 3D. And this is not that complicated. But if you zoom in, you can find out some, okay, higher LOD image just loaded, okay, based upon your zooming in, zooming out operation, okay. This is so-called geometric level of detail. Okay, let me show you another case. Let me zoom in this one. Okay, Google now loaded higher level of detail geometry in order to see this building's geometry precisely. How about this? It's looking coarse, but now higher resolution level of detail image just loaded. So thanks to this kind of operation and geometric 3D making, we can reuse this kind of 3D geometry without any problem, okay? So acquiring 3D before this kind of technology, before 1-to-3D catch, before smartphone devices, around 20 years ago when I was in school, making campus 3D, building 3D, city level, urban level, what we should do at the time. SketchUp modeling, 3D Max modeling, AutoCAD modeling, again and again, okay? But nowadays, what you need to do is just flying drones, okay? Or satellites, some airplane pictures, enough for making 3D. So we are living in this era. So this is 3D model view based upon Google Earth. What do you need to know? Next week, next after next week, probably rest of the semester, your main subject, your main application is going to be SketchUp, V-Ray, and related design representation tools, okay, in 3D. For being a powerful designer using computing technologies, what do you need to know? Again, this one, specific computer applications for CAD and graphics tools. Even if our lab exercise doesn't deal 100% of those tools, I told you, I encourage you, teach yourself. Even much more things about design computing, drones, photogrammetry, laser scan, 3D printing, and so on. Such technologies are very critical and effective for your design development. That's my point, okay? Okay, for today's lab exercise, we're gonna have another quick break, okay? And move on to the lab exercise.